Been a busy few weeks up over here. Last week we showed you the studio remodel. This week I'm going to show you the new control system that I made for the test track up here. All pretty, all organized, plus made an amazing Ogauge 3-rail AC and S-gauge AC control panel as well. Absolutely gorgeous. They perform flawlessly. I'm Ron with Classic Model Trains. Follow along and I'll show you how I built these beautiful control surfaces. I just got done building this sweet work center over here, this big workbench, but now I have to get something for my test track. I got to get this thing powered up so I can use it. HOscale, it's going to have HOscale on it, and it's going to have 3-rail O-scale. I want to build just an awesome control system for it. One that I can test amp loads, voltage loads, DC voltage loads, pin ins, pin outs on it, kind of like the Lionel test platforms that they made back in the day. I'm going to show you how I'm going to go about doing this. It's going to fit in this section right over in here. Now it's going to be similar to this control system that I made right here for my DC and DCC, the HO stuff. There's a controller, the MRC 20 2.0. I don't know what it's called. These things here, they're absolutely awesome. And it lets me put in an amp gauge and a volt gauge to test electrical loads. And then I'm able to control it DC or DCC by a dual pole, dual throw switch. That'll come into play a little bit later. Now, little did you know that MRC also makes these things for AC power, where you've got the walk around throttle like this, and it's got the whistle, it's got the bell, which is on like later on stuff, brakes, direction, but this can control 2 separate tracks. So I can do S-gauge, and I could also do O-gauge, since I got 2 tracks coming out, throttles going on, the whole thing. So this is going to be power to the brain right there. These are all the components that I've bought for it. I made sure to buy all matching gauges, voltage up to 30. Lionel will put out 18 volts, and I couldn't find a 0 to 21, so this was the smallest voltage that I could get that goes up as high as I need it. Amperage, 20 amps AC. This is voltage DC, because it has a DC rectifier in it that sends signals down the track to activate the air whistles. So we need to be able to check that also. Momentary buttons, all this stuff came from Amazon. We can use for uncouplers, operating cars, came in a 10-pack, had to have it. 120 volt lights to let you know that something's energized, because indicator lights. If we're gonna build it, let's build it. These are banana plugs. And these are for speakers, I found out. And I can use these, which are test leads for DC power supplies. I just got to kind of expose the end. I got to cut some of the end off right there to plug them into these for pin ins, pin outs. Let me show you what the NapCAD looks like. Here's what I drew up here a month ago, trying to figure out what I wanted to do to wire all this up. And one of the things is try not to take it in all at once, because it looks like there's a lot going on here. If we just start over here, you can see that this is just a transformer. And it's got 120 volt coming in right over here. Well, this is going to be plugged in all the time, and I don't want to have to reach back and turn the power switch on this. So I'm going to have a panel mounted toggle switch. Because, you know, you have to. Oh, that's even got an indicator light on it, doesn't it? Yeah, it does. Well, then I don't know why I bought one of these, because I ordered these, the end of it lights up when it's turned on. But we'll get it figured out. That's what this is. That would, let you know that, hey, the power to the transformer is on. Transformers for AC, variable voltage, has only got 2 outs coming out. And what I wanted to do was have a dual pole, dual throw switch in. They look like this on the back with 6 connections. So that way I could run transformer, it's pointing towards the transformer, and this would allow the voltage to go from the transformer up to the track. Or I wanted to be able to test transformers. So if I brought one of these in, I could have some test leads that come off a transformer. I could plug it in, and then I could run it through the rest of the track, going to power the track. That's what this is right here. Center rail and the outside rails are, of course, a common. It's just basically just 2 wires that come off here and here that are going to go up. DC voltage. One of these right here will be put in. AC volts. One of these right here just ties in to the two wires going up. Now AC amps, the power's got to flow through the meter. That's why it shows this one hooked up here and hooked up here. This just means that it's not connected right there. But this one says that the juice is going into the meter, back out to the meter and up. So that is what that circuit will pretty much look like. That's really all it is. Toggle switch to turn the power on and off. We got a lead, separate lead coming in like this. And of course I can't get the MRC thing up here, but that's all that's going on. It's just got a lot of what looks like there's a lot going on. There really isn't. At least right now, because I haven't started wiring it yet. It could go completely sideways on me once I get going. So here's our work area here. It doesn't really need to be very big. This is as big as it was on my desk, the original one, for 4 years, and it worked just fine. I'm not even sure if I need 2 of these. These are just like small toolboxes. And I was like, I've never even really bothered with that. Get that out of here. So we got a soldering station. We got our primary tools that are used all the time. So I can start that right here, the board. I got to cut a piece of plywood to mount all the gauges and all the switches in. We're going to put this, it's going to be hidden behind the panel right there. Hopefully that works. I might have to turn it sideways. Necessary electrical components, and I got to design these panels. Cut out some 1/8 inch ply and then lay it out. How is this stuff going to be set up on it so that it makes sense? Plus put in a couple of these that will be coming off the AC side of the transformer. I didn't really draw that in yet so that we can control accessories on the track. Lots to do here. So I'm going to measure up how big I want these panels to be and then start to lay them out. So here's our first panel, 9 by 22. I've marked off 3/4 of an inch up here because that's where it's going to be touching the layout at the test track. And then down here, we're going to have another board like this that's nailed down to the work surface to secure the bottom of this. So we don't want to put gauges in that neck of the woods at all. Center line through it because we're going to have S and we're going to have O. So now I'm just going to find a way to creatively put these gauges in so that they make sense. And then all the appropriate switches and buttons. And, you know, what, I guess just be creative wherever I decide they're going to need to be. These guys here, they're a panel mount. So they're set up to go into round holes. Here we see the size of the hole right there. What is that? It's a 2 inch. These are using 2 inch holes. So I'll use the compass to draw a 2 inch here through there to do, I'll show you the layout stuff. So make it pretty, get all the holes drilled out, and then we'll paint it. So with careful deliberation, with everything I wanted on this piece of paper right here, this is what we got. The controller, because it's got to sit up on the panel, and then this is the jack that it plugs into, because I want to be able to unplug it so I can put this away so it's not laying on the board when I'm not using it. So here's our main power in. Here's our power LED that will light up when the unit is energized. Here's our gauges coming through. This is the dual pole, dual throw to send the power either to the track or it can come in from an external transformer. I'm kind of doubling it up because I'm making 2 systems separate just because that's just what I'm doing. This is an output right here. So if you wanted to use the MRC transformer to test stuff like a motor that's sitting on a cradle, you put your power leads into there and then you could roll this up and down. And then these are going to be for uncouple and operating cars, both in both in O and S, doing the same thing. So I'm going to lay them out. I drew these lines to give me ley lines here, figure out where all this stuff is going to be. Circles, hole saws, drill bits, drill it all up, make it pretty. Now some creative laying out of the mounting holes here. Now I believe our gauges are going to fit wonderfully. Voltage. Okay, wait, this is... Oh, still got the nuts on the back. That's why it won't fit. Voltage. Voltage. Amps. Gotta do a little creative filing, I guess. Voltage DC. I gotta knock these little things out right here on them. Let's give that a spin. So there's all of this in. I got everything else marked out and the size of holes they need to be. So I'm going to drill a smaller pilot hole in here, like 1/8 of an inch or something smaller, just so I can center everything up, and then I'll come through with the size of bit that we need. So I've been laying this out now quite some time because I want it to all match quite nicely. This will have a holder right here. This guy's going to go right here. Somehow I blew that hole off. So I gotta do it again. But I can cover that up with the plate, so that's a bonus. Warm up that drill press that's in here and knock this out. Second coat. And after just a few short hours, this is what the face of it's going to look like. I got a little label machine and I can label these, but it's going to look like ick, and wish I could get like really nice labels somewhere. But that's a problem for future Ron. This just split 50-50. This is exactly the same as this one. Switch it from Ogauge, S-gauge, Ogauge, S-gauge. Yep. Gotta make a little holder for that. Looks like I don't need to make a holder for that. I've already got one. Right on. This is for the NCE power cab right here. I bought it from somewhere a long time ago and forgot all about it. Get this out of the way. Oh, this electrical tape, because, you know, I put the paint on so thick that there'd be no way to ever paint a nice line on there to get it to look this good. I did that on the Tyco layout also with the red, because I can't pinstripe that nice at all. This is the back, so now it's time to start getting this wired up. We'll work on that tomorrow. This here's how the HO portion of the control panel is going to be. A separate panel. We got the DCC, which would be like this. Flip over this way to run the DC, and then you've got power for each individual transformer, since this is self-powered all on its own. Then I realized I forgot to put in ways to bring in outside power sources in. So I'm going to go this route right here. I'm going to put these in. This will allow me to tie in an outside transformer. I flip the switch to it, and then it'll route the power through, you know, this switch here. I'll draw a NapCAD for it, but I got to get some extra holes drilled in here. This here is going to be track output, whether it's DC or DCC. It's just going to mimic exactly what the track is doing. So that way you could bench test stuff with test leads right in front of me here, not on the test track, which is sitting just right there. So here's the HO control board, all done. Three-way switches, three-way switches, three-way switches. Let me draw a little NapCAD of what this is actually doing. MRC Control Master 20. Now going to the track, there's just two wires that come out. And we're going to have the track up over here. Now I want to have two inputs for power to come in. So there's the auxiliary input right here with two wires that will, you know, basically be coming out of it, positive and negative. This is where we run into our first dual pole, dual throw switch. This is going to come in on this side. This will come in on this side. And then this is going to come out. How am I going to draw this? To go this way. Now we've got the other dual pole, dual throw switch that comes in from the DCC, the NCE power cab. Now since it's all self-contained, I also want a separate DCC input in on it. Two wires are going to come out of this, and they're going to go to the first dual pole, dual throw switch. I didn't plan this worth a poo. These two are going to come out, go to this. And then these center ones are going to come out, go to this one. And then basically this second dual pole, dual throw switch goes up to the track. Auxiliary in, dual pole. This would be normal, up. This would be DCC. This would be DC. This is just the exact same thing as the track output. Whatever it's outputting, there's just something right here. These gauges are controlled by the MRC Control Master, amps, volts. Because the way the Control Master is set up, they've got its own separate amperage and voltage outputs. So that's just simply Control Master stuff for the DC side. Now, if I can find myself, they do make DCC volt and amp gauges, which would go in to this wire right here. Well, actually, it would come off of this one, is where we'd want it to come off of at. But I have not found one that I like yet, that's got a nice panel mount to it, so I'm going to shop. Maybe you guys know what's a really good one. I know NCE makes one, but it mounts up silly. I'm sure there's some other ones out there. We'll figure it out. This is that separate out here, one wire here, one wire here. And that's kind of a simple flow of the way this works. These ones right here just simply turn on the power to either the DC or the DCC as you switch back and forth between them. And then these are just power indicators to let you know that the transformers are on, because I like to forget about it. So this is to help with that. I get a lot of emails every week about people that want to promote their products on my channel. And I don't do it because, for one, I haven't found a product that I think is worth anything to promote on the channel. And then I realized I've got a really important product that I should promote on the channel, Classic Model Trains World. I think the most important one is our members that are out there. They're providing the most amount of extra income that comes into the channel, well, week to week or month to month. I want to thank everybody that does support the channel through our memberships. It's all through YouTube. There's a join button at the bottom of the videos, every one of them. Click in. and it'll describe how that works, how it breaks down. People are always asking me, how do I become a member? That's what you got to do. You got to be subscribed first to become a member. That generates lots of extra income, and it helps support the $1 club layout for the storage of the building that it's in right now. We're about halfway through the video right now. It is an excellent time to do classic model trains, classic model of the week. Do you guys know who this is? If you do, type it in the comments down below. If you don't, hang out till the end. I'll let you know who it is. Let's get back into working on this stuff. I ain't got no holes up over here for electrical cords to go through. We need to have the DCC one and the AC one sitting over here, and the power supply for the soldering station, whatever other things I can find up there. These are pass-throughs. You drill a hole, run your extension cords down, you put this in, cleans it up. So I need to get in there and drill a couple holes. Then we need to get this out of the way, get it where I can work on it, and I'm going to put in an HO track up in here. Oh yeah. This is our dual switching for the DCC and DC transformers right here. We're using this cork from the old layout, and I like to nail it down because I changed my mind so much. I'm always pulling it back up. And boy, when you glue it down, especially with some wood glue, yeah, it's a done deal. That you ain't moving it, digging it up or nothing. I drew a straight line down the center, then I'm just lining up both pieces of the cork on the center line. Then when I go to nail the track on, I'll just use the center of the cork to perfectly make the track straight. So it's just a win all the way around. To make a proper test track for Lionel 3-row, you definitely got to have one of these. The uncoupler and I hope this makes the automatic car automatic. It probably don't. I don't know. Maybe it needs the extra rails in it. I've got every one of these sections of track. They're nailed down. They're soldered in. I had to take the solders off, the drops, to get them to flex just enough to get that old piece of track out and get this one in. And the wires, of course, were all rotted off. So I had to solder in new control wires for all this to take place. I put this back in, nail the track back down. Then it's time to start soldering drops and put a bus in for this. So I got a seam right here. There's only 4 pieces of track on this. So I'm going to put 2 right here on, so both sides of this. This is redundant. Every piece of 3-foot track is going to have a drop on it. And then the other 2 are just right here on this seam. I thought about just soldering it all together and then making it one. If it expands and contracts due to variables in temperature, then I might have to cut a rail open just a little bit. So we'll solder these on, flip it over, and then we'll run a bus line. I got some scrap wire that I keep all my junk scrap wire and stuff so I can do electrical things. So this one will be white and blue. Here's our drops coming up right through there on the bus wire. So we got 3 bus wires, Ogauge, HO, S-gauge going down. I put these to go to the control system, and the tape, Gorilla Tape, maybe it'll hold these wires up a little bit so they don't sag underneath there. Might be a good idea, might not be, I don't know. Here's our 2 wires for the control track for the Ogauge, and these are the wires for the bus. We're gonna put it up here and start assembling the panels now. This is what the back of the control panel for the DCC looks like. And the schematic was a lot easier. This NapCAD drawing right here, of course, makes it a lot more clearer than this mess. And I even tried to make it look clean, but this is the way it comes out because the way that it is, I guess. Power and everything hooked in. Thank God this side's nice. I just tested it, the lights come on and the things power up, but I haven't completely tested it out yet. So let me get it in place, hook up the stuff and see if this one is working, because it's just a horrible mess over here. So this looks a little better. We gotta do something with this though. These are a special cable that they make just for the NCE, and 2 of the wires are a thicker gauge because they're basically the bus wires going into the thing over there. So you can't just go and get a normal phone cord like this, because I tried that. That won't happen. This is on. Center one, DC. These ones here are in. And if I wanted to use this one here for an external DC transformer, I plug it in there, I switch this over like this, and then I could run it with same with over here for a DCC input. So right now we're DC. This plug, it's giving me problems and I'm running out of time. So that does what it's supposed to. We got these guys on board. Yes. Loving it. And the old Tyco DCC with sound and stuff. Oh yeah, wheels are dirty. Gotta clean the wheels, gotta clean the track. I've never done that. Yep. But the DCC side is working also. Now I gotta go build the Ogauge stuff. I wired up just the minimum amounts on this to try to make it easy enough to read, to see what's going on here. So this will be AC volts, AC amps, DC volts. So we've got into the dual pole, dual throw switch right here, because we've got the optional input sitting right here. So we've got it set up where it's coming out of the power pack or the transformer for track 1, which goes off to the one side of the DCC, which on the schematic is right here. The center one is the power that's going to give us everything going up, and then here's that other auxiliary input, which is right there. I took the amp gauge, has got to be in line with the load. As you can see on this one here, one wire goes into the amp, one wire comes out and goes up. So here is our load going to the track. You can see one of it comes off of here, the amp gauge. The other one feeds in right here, going to the center of the dual pole, dual throw. And then for the volt gauge, I just took 2 wires and put it right to the center of this here and this here. So it'll work whether it's got the external input or the transformer input. Now the DC gauge, I'm not sure if I can just hook it in with the AC. I'm going to try it with some temporary clips from here to here and here to here for the DC. And then that'll give us everything we need. There's no power hooked up. This is the power circuit right here. This is the other circuit, like the S gauge circuit. And then these are just the buttons for the accessories. This jack here, we've got it working. I've got this little beauty right here. Give it the juices. You see we're pulling 12 volts. Tiny little bit of amps. Jesus. Interesting. There's a lot going on right there. I'm going to jumper the DC volts and see if our whistle horn relay is putting DC voltage out. So I just jumpered them directly straight across. I have no idea what's going to happen. Put that thing in neutral. I'm going to hit the whistle button. Will this move? It's going backwards. So I got to reverse these wires here. Yep. Fantastic. Ooh, that thing needs some lubrication. I just pulled it out and threw it up here. That's working. That's exactly what I'd hoped for. So now I'm just going to build some jumper wires, white wire to the outside, green wire to the inside, and just connect it up in here. And that circuit is done. Basically, it's finished. Awesome. I'm going to do a quick hack on this transformer power supply. This is just the electrical cord that's coming out of it. I don't want to have to reach in and flip the switches. I want this little indicator light to come on. So what I'm going to do is I'm going to take one of these wires, cut it in half, and then I'm going to put a spade connector, one here, one here. One of these wires will be in that spade connector, and then the other one that I don't use will be spliced in to the wire that's not cut. And that'll give us everything we need, down and dirty. I'll show you what it looks like when it's all said and done. So here's how it looks. Broke that wire, just peeled the insulation back, put it on there. I'll solder that and tape it when it's all said and done here. So now I've got this option. Light is on. Loving it. These are a couple buttons right here and unload buttons. It appears that they need to have ground and they need to have the power. And it's AC, and I know, but you know, these are the 2 wires we got going on here. There's 2 sets of wires that come out of there. They were cut off, they were rotten, so I just soldered new ones in, not really knowing how these work. And I figured they're just an electromagnet, and you just put juice to them, but no. One segment's burned out. The center one works. They're wired into ground, and then it needs track power too. I've got this one working, and this one here, it doesn't. That's my only 027 uncoupler track, so I'm gonna have to order a new one of those in and then redo all this again. Let me show you some of the joys of these ins and these outs. So this is an auxiliary out over here. These are just, they're mimicked. So let's say if you're working on a locomotive on the bench, this is now also the power supply. So it doesn't have to be on the track. It can be down under here. But see, I got it upside down, so the E unit isn't going to work right. Sure, only got the one hand here. So bench testing with this. And you can also, it's got the gauges that are all still fully functioning, just as if it was up on the track. That's our output right there. Then I can go into this input right here, switch this dual pole, dual throw switch to it, points at this, and now I can test other transformers. I bought these really nice test leads here. Oh, you rotten. I screwed it in. They got interchangeable ends. You can put probes on them. You can put these big things on them. So now I can test transformers out with the exact same track, and the gauges will still work. Couldn't be happier. That's a good little transformer right there. So that's what all this was for. I over-engineered it just a bit, but it looks cool, doesn't it? That was the goal. Seems like I've been working on this studio for 3 weeks now. It took a solid week of just doing this because of my minimal amount of work hours I can get done in a day. Golly. I got my studio lights up. I'm running halogen bulbs and everything. I've got a dimming system. The stage dimming system is up. I bought it almost over a year ago and never used it right because the LED bulbs don't like dimming. Oh God. You can only get an incandescent halogen bulb from China, shipped in through the Amazon because we're not allowed to have them here in America. Oh my God. I got to do labels on these things. That's going to take some time. I mean, I've been pounding this all day Sunday to get this video out. So they're not completely labeled yet. And the S-gauge, the second half of the O-gauge over here, I didn't finish it up yet. I probably fell out of frame on that one there. Painted these guys up red to make this look a little better. More interestinger in here all the time. I'm all anal trying to keep it clean. Vacuuming the florals. It's got that new car smell to it. Be interesting to get to work on some stuff, and it looks like this is going to be the first one to work on because it needs a complete lube job. And I suppose that circuit board in there probably has got the foam underneath of it that's rotted out, and I thought about that. It's like, I'm glad I didn't short out the sounds of steam board in the thing. That's one of the downsides that they have. Our classic model of the week, Mae West. She was in the movies I think even before they had color. I think before they even had sound. I'm not 100% sure. I should do some more research, I suppose. I want to thank all the 33%ers for hanging out with us. We made it till the end of the video. If you guys wanted to see some more wiring videos, here's some that I've put together right here in the past that have a lot of background of why we're at where we're at right now. So we'll see you guys next week. I'm Ron with Classic Model Trains. Bye-bye.